Hello. What is a special announcement? I didn't say special announcement. Nobody ever said the word announcement. I said it was a special stream. It is a special stream. We're going to be doing some programming, but the programming will be fueled in a different way than usual. Well, in the same way as usual, but in a different way. We'll explain in a minute. I got to finish getting set up. Okay. Maybe. All right, so viewers of the stream know that Golden Monkey tea is the key to being able to program. They know that it is delicious. And people ask me sometimes, what is the best Golden Monkey tea? And I say, well, I don't know for sure, but I get this one off Amazon. And it's pretty good. But I didn't really know. And so today is the day we find out. Excuse me. I have here a selection of 5 of the finest Golden Monkey teas known to Jeff Bezos. Okay? I will describe to you what they are. And then over the course of the programming session, we will be trying out some of these teas, all of them actually, and we'll be scoring them along a spectrum of factors that I don't know what they are yet exactly. Anyway, so here's what these teas are. Let us run down the teas. Now first is this full chi Golden Monkey tea, which, as far as I know, is the one that I've been ordering. But the package is different now. Okay. And what does that mean? I don't know. Is it the same tea inside? I don't know. Is it as good? Has it been blessed in the same way? I don't know. We will find out. 2, also in a bag is Tea Lira, the galaxy of teas. So there's a whole galaxy, like in Men in Black. And this one is made out of tea. Yunnan Imperial Golden Monkey. So we will be trying that. We're going to try this one last because it may be the one that I'm familiar with. It says medium caffeine, fruity taste, mild, smooth. I don't think of it as having a fruity taste. Okay, next we have Master's Collection Golden Monkey. Organic black loose leaf tea. Ingredients, organic black tea. Tea blooms, organic Golden Monkey tea leaves, are grown at the altitudes of 1,200 meters in the cloudy and misty province of Yunnan. This highly prized tea is hand processed each spring, so it's been a while, with careful plucking of only 1 leaf and 1 bud. It produces a smooth, deep, and slightly malty flavor. The complex black tea can be enjoyed in multiple infusions. In other words, if you're a cheap ass, you can just keep flushing water through it. Okay. Number 4. Special Reserve Golden Monkey Golden Tipped Black Tea. From the Tao of Tea, which I think they thought when they started the company was Tao of Tea, and it was cute to say that. Origin Fujian, China. Grown near the Taimu Mountains of Fujian Province, Golden Monkey is also known as Panyang Wang, the king of high-grade black teas. Only certain tea plant cultivars can produce golden-colored leaves. The golden color emerges during processing after accurate withering, moisture drying of the leaves. Few areas in Fujian contain these cultivars, which makes Golden Monkey a specialty in the region. The tea term monkey in China refers to the fuzzy golden hair down on the leaves, which provides a texture and smoothness to the brew. There's like 18 paragraphs here. Best season. Golden Monkey is in season during the spring, April to May. Since it is heavily oxidized dark tea, it maintains its flavor well over the months. In other words, if you're having this in December, it shouldn't be too bad. Judging quality, there are several grades of Golden Monkey, and we recommend these with long, full leaves, consistent gold color, and sweet aroma. Flavor profile. Uplifting, full-bodied brew with honey texture and a very pleasant, toasted, sweet aftertaste. You notice all three of these have used different adjectives to describe the flavor. You may draw whatever conclusion from that you will. Brewing Golden Monkey. Brew 1 teaspoon of leaf in 8 ounces of filtered water at 185 degrees Fahrenheit for 4 minutes. Yeah, we don't pay attention to any of that stuff. Okay, last one. Golden Moon Teas. Golden Monkey. Grown, not made, no added impurities. One of the sweetest black teas, crafted with golden tea tips. That doesn't make any sense. Natural does not mean from Mother Nature. Most teas are no longer a product of nature. So-called natural flavors are chemically based. Blah, blah, blah. They're giving some eco person. Yeah, this tea is going to suck. Okay. We'll try this one first. All right. We also, by the way, as palate cleansers between bouts of tea, we have albino strawberries and cake. So you got to have palate cleanser. Okay, we have started the water boiling. Each tea will be tasted in 2 rounds. First round, just straight tea. Second round, with milk and honey. The honey will be world famous Greenwise unfiltered orange blossom honey from Publix in St. Petersburg, Florida. You know, I was going to program a bunch today, but my brain kind of isn't there. My brain wants to rest from programming. So maybe we won't program that much. Maybe we'll do like Q&A. Maybe we'll do public Q&A about the programming language. I don't know. I don't know. So this tea comes in a bag for freshness. We will now open the bag. We will dispense the tea back into the tea canister whence it came, which is a little more difficult than I wish it was. Okay. The scent of the tea. Honestly, seems fine. It's maybe not that strong, I would say, which could mean it's old, or could mean it's just not that strong. The sticker on the bottom says 11/17/25, which I guess means you shouldn't drink this after 2025, which any tea that has like a 3-year expiration date on it, that again leads me to believe that that tea is going to suck, because tea doesn't really last even like 6 months. I mean, it's fine. It's okay to drink tea after like 6 or 8 months, but it's simply not as fresh. Public Q&A sounds like hell. Well, we could see how that is. Just to let you guys know what I've been working on lately. You know, the other day we were looking at the profile. Some people were on this stream, and I was trying to narrow down the time being taken, and it seemed to me, I didn't run VTune or some tool that would accurately diagnose cache misses, but it sure looked to me like the time was being taken just in memory references, because we narrowed down everything else, right? And so I decided there's 2 things to do about that. And this was in identifier lookup. And there's 2 things to do about that. 1 is reduce the amount of memory, and 2, change the identifier lookup strategy. Since the nodes in this compiler have been pretty thick, THICC for a long time, I decided to try to start removing data from them. And since that stream, you know, yesterday, I didn't work that long yesterday, but I managed to get 16 bytes out of the base node. It went from 104 bytes. And this is, you know, this is like the base node that isn't actually enough yet to represent any particular node in the syntax tree. It was, you know, it's the one that they all have in common. So every single node used to start at 104 bytes, which is really big. I mean, for me, like, it's tiny for anyone who uses JavaScript or whatever, but you know, so we got that down to 88, and another 16 should be relatively easy and is in progress. So we should be able to get that down to 72, which still is a really big number. And then after that, I'm not sure, but that, you know, one step at a time. So we get the base node down by a bit. And then, you know, that particular code was iterating over the scope structure, right? It's called ast block in this. And so reducing that could be a thing. One thing I could also do is separate scopes from blocks, right? Because those have been the same thing the whole time. I don't know if that's worth doing. What's the difference? You know, like a block holds a sequence of statements, right? And a scope is, you know, bindings, name to value bindings. The thing is that those 2 things go together all the time. So they're together. Let me get the water. Water. Okay, we are going to standardize so that this is a fair competition. We are going to standardize on volume of tea and time of steeping. Okay? We don't have that much precision over water temperature, but we'll try to keep it consistent. So I don't use my Tim Apple phone anymore, but I still have it. Oh, look, it's been running. The stopwatch has been running for 855 hours. At least. Maybe it wrapped. Okay. Yes, so we're going to use this same spoon every time. And I'm going to do a very heaping. Now, you know what? This spoon's too small. For the way that I like the Golden Monkey, let's get a bigger one. Okay, big spoon. Big spoon. Okay, I'm going to set the time. I'm going to preset the timer to 5 minutes 0 seconds. 5 minutes 15 seconds. I'm going to get a big heaping spoonful like this every time. That is the amount. And it goes in the teapot. And then the water goes in. And now this part has to be very consistent, right? So the water goes in. All of this water is filtered through a Berkey water filter, by the way. Okay, we put the lid on. We press start. 5 minutes, 15 seconds. And this tea goes back to the competitor circle. One minute has already elapsed. Are there any questions about, let's pick a specific topic, like optimizing a program like this? Any questions about that? Will the chartreuse be tested as well? That might be a good palate cleanser. Is the chartreuse. We could go bigger. One thing I noticed disturbingly during when I had the camera picture bigger like this is that like autofocus is frickin' turned on this camera, and just like every autofocus, it serves to pull things out of focus all the time. So that's annoying. I didn't want to take the time today to figure out how to turn it off again. But sorry. Sorry. How do I like telemetry? Would I recommend it? It's okay. Yeah. Like, it doesn't seem to have changed very much over the years that I'm using it. And that's not surprising now since RAD got bought by Epic. And so the question is that I don't know the answer to is there ongoing development of it as an external product? I kind of doubt it, right? I kind of doubt it, but I don't know. I don't know. It could just be done too. I mean, I know ways to make this better, right? I don't know if they would agree, but I could think of plenty of things to make this better and even more helpful than it is. Although it is very helpful as it stands. Ugh. Code view. Code view. Takes us frickin' I don't know why we do that right there. Actually. Oh, I sort of do. How did I suspect cache misses? Well, because when you're looking up and down the function for like what's taking all the time, first you look for non-trivial operations like calling other functions or doing weird loops or whatever, right? Simple statements that don't have any path complexity. Oh, hold on. Timer's done. You know, simple statements like that don't take very much time unless something is making them take very much time, right? Okay, so we're going to pour the water. Or the tea, really. It's not water now, it's tea. Okay, this is the smell is actually, it's pretty not bad. Once again, for review, this is the Golden Moon Tea Company. Golden Monkey, one of the sweetest black teas crafted with golden tea tips. All right. We got to let the water cool down a little bit more. Initial impressions. It's pretty okay so far, but it does taste a little old to me, like I was saying. I suspected. It does not taste like fresh, bold, hearty Golden Monkey tea. Remember me mentioning more than one heap. Is there any C++? Hold on, I can't see. Is there any C++ book I recommend that talks about deep performance issues like this? No, because C++ programmers don't have any clue about performance, really. Like some of them do. I mean, I don't mean to make that a blanket statement. Some of them do, but broadly, the broad-based C++ community right now has no idea how to make programs that run fast, which is sad because they should, because that's the whole reason you would use C++ instead of another language. But they have like lost the idea. Okay, let's talk about why you would have more than one heap. So when you allocate things from a heap, what happens? The heap is just some large amount of memory, right? It grows over time. You know, underlying your memory requests, the heap algorithm that's implementing your heap will, I mean, that's a confusing, like the word heap never mind. Anyway, like heap is also a data structure, but when we say heap for memory allocation, we're not referring to a specific data structure. Like historically, it's called that because what the earliest implementations were specifically heap data structures. But when we say a heap, when we're talking about memory allocation, we don't really mean anything specific in terms of implementation. We just mean it's a place where you can get arbitrary sized amounts of memory, and the lifespan of that memory persists until you explicitly release it, right? Unlike the stack. That's what we mean by the heap. So, you know, the model, going back to C, was pretty simple. Is there's one of those for the whole program. And when you allocate things, where do they come from? Well, it comes from anywhere. You don't know, because you're not supposed to think about that detail as the programmer, right? When you allocate multiple things, one after the other, where do they come from? Are they next to each other? Well, maybe not, right? Because if your program's been running for a while, maybe you know, you freed up some memory previously and that was available, and thing A goes here, and then you freed up some memory over here and thing B goes here, and so A and B are not near each other. That didn't used to matter because nobody used to think about or care how close two things were in memory to each other in the olden days, right? But the thing that has changed since the olden days is that now memory accesses, or more specifically, reads from main memory have a much, much higher latency than regular CPU instructions, right? And so, again, to recap how insane this is, if you look up, you know, this varies by CPU, but if you look up how long it takes to read from main memory, it's like 400 to 500 CPU cycles now, right? Of course, this depends on specifics of the memory and the CPU. But that's more than 500 instructions, right? 500 is a very round number because 500 times 2 is 1,000. So I'm going to use that even though it's often more like 400. This tea is okay. There's something that I don't like about the flavor. There's something a little bit bitter in there, or like, I don't know, pesticide-y. So if you look up how many instructions you can do, or how many operations you can do, even on one core, Casey has pointed this out before, right? You can do like 8-wide SIMD on floats if you're doing multiply adds and retire 4 instructions per clock. So you could do 34, let's say, floating point FMADs. Sorry, 32, 34. Did I say 34? The golden monkey is getting in my brain. You could do 32 multiplies and adds times 500 in the time it takes to read 1 byte from main memory if that byte is not cached, right? So that's 15,000. Like, just think about, so a 4x4, let me, right? It's still early in the morning. So if you do a 4x4 matrix times a vector, I use this as an example in a speech I gave recently, because it's like talking about one multiply add is a pretty abstract unit to think about, right? But, you know, a 4x4 matrix vector multiply is approximately, right, 16 multiplies and 16 adds, right? So you can do that on most modern CPUs. You can't do that whole thing specifically in one clock, but if you're batching a bunch of them together, you can do them in one clock each, right? So you could do 500 4x4 matrix vector multiplies in the time it takes to read a byte from memory. Mad counts as 2 instructions. Yeah, but like that, what I'm talking, so 16 multiplies and 16 adds is 32 ops, right? Which is what we said we could do. CPUs are pushing 6 gigahertz now. Yeah. I mean, that's slowed down a lot. 20 years ago, we had 4 gigahertz CPUs. So like it hasn't, clock speed has not increased that much. Okay. So just, you know, and again, the exact how many of whatever you can do, again, it varies, right? If you have an older CPU, it could do less. If you have a newer CPU, it could do more. But that's the basic idea. You don't need to know specific numbers. The basic idea is you could do a metric boatload of math in the time it takes to read 1 cold byte out of memory. Now, the CPU is designed to avoid this problem as much as it can, right? It goes to very heroic efforts to cache things. And so if your memory's in cache, you're better off, right? And there are several layers of caches with increasing latency. Even if you're in, you know, L1 cache, I forget how long it takes to read from L1, but it's like several cycles, I think. It's like 6 or 5. I might have that wrong, but it's not free either, right? It's not like having things in a register. We could look these up, but again, we'll get caught in the rat hole of browsing all the web pages, and I don't want to do that. So well, because the caches still are significantly faster. I mean, so L1, I'm going to say 4 to 6 cycles. I don't know. It might be 2 sometimes. I'm pulling that number out of thin air. Somebody can say in chat what it is. Someone says Ice Lake is 5 cycles. Okay, so I wasn't far off. You know, L3 is like, I want to say 70 cycles or 100. 70, 74. That's just the heuristic that's in my brain, right? And L3 is quite a lot bigger, right, than L1. L3 is 41. Okay. So I was more off on that. But the general pattern, right, is you have smaller caches that are faster, by which we mean less latent, right? Like how long it takes to get data from them. And you have bigger caches that are further away, right? So the speed at which your program runs, given that it reads a lot of memory, which basically every program today does, the speed at which your program runs depends on how often, well, what percentage is it reading out of cache, right? And then also which cache, right? So reading out of a cache is vastly better than reading from main memory, right? And then if you can be reading from L1 instead of L3 or whatever, that's also a lot better. L3 can be gigantic on modern AMDs. Yeah, that's true. How big is L3 these days? $64 megs. Yeah, so that's pretty good. That sounds like a lot. The problem is that software these days is so bloated that 64 megs is not necessarily as much as you wished. But yeah, so, and L1 is what, are those, I mean, the heuristic in my brain about L1 is like 64K. It's probably like 256K these days or something. Like, how big is L1? People who pay more attention to this than me. 768K now. 384. Okay, we're getting all kinds of numbers for L1. Okay. So less than a megabyte. Right? And so you can just have these heuristics in your head, right? So it's actually convenient that these are about a factor of 1,000 off, right? So like L3 is about 1,000 times as big as L1, right? Something like that. On a modern high-end CPU. Okay. So to get back to the heap thing, if you know that memory is going to be used at approximately the same time, you want that memory to be close to each other, right? Because it is likely, this also doesn't determine that, but it is likely, all things being equal, that when you do reads, they will be more in cache, right? Now, of course, if you're not talking about using a heap, or you're talking about something very big on the heap, you can start talking about storing things internally to some data structure where you exactly know the access pattern and it's all planned out, right? But if we're not talking about that, if we're just talking heuristically, then I was just starting to think it's unfair if I let the tea get cold. So I'm going to proceed to the milk and honey phase now. I might have used too much honey. The problem is I need to make the honey last for all the teas. And I don't want the tea to be dominated by honey. Although for this one, I don't mind. I would not, I'm going to dump this tea after I'm done because it's not something that I would drink. All right, we've got milk and honey, and we're going to see how that goes. So if you have one global heap for your entire program, as is traditional in C, or still in C++ as far as I frickin' know, right? Then all allocations across your program are basically mixed up with each other, right? And so you're not getting particularly efficient use of your memory. Now, the thing to know, right? So these caches, if your memory is not organized, these caches are smaller than you would think because they're divided into pages, right? And when you load data from a cache, you load a page at a time. And if you only care about, let's say, 8 bytes out of that page, the rest of the page is wasted, right? And so what you really would like is if you're going to read through pointer 1 and then pointer 2 and pointer 3, you would like the contents of pointer 1, pointer 2, and pointer 3 to be on the same page, right? For whatever the page size is of these various caches. Which, you know, for L1, pages are pretty small. Yeah. So, reason number one to have separate heaps is simply so that you could keep like things together, because that will help with your performance. Now, another thing that I brought up the other day is that we're also leaving the time when you can pretend on a multiprocessor system that all processors are, what should we say? There's a term from graphics that I'm blanking on. anisotropic or isotropic. Most programmers pretend that CPUs like kinda are just like in some abstract place relative to the caches, and they can just read from the caches and it's fine. And they can just read from memory and it's fine, right? In a multiprocessor system, the CPUs aren't magic, right? And it has to be it has to be implemented that CPUs can talk to the various forms of memory, right? And this involves generally a hierarchical scheme where some CPUs are closer to some things and further away from other things, right? And so again, if you pretend like you can read any memory from any core with equal speed, you're going to suffer some penalties. Like if you have, let's say you have one CPU writing to some memory and another one reading it, that's going to be a lot faster if those two CPUs are next to each other than if they're far away. Okay. I'm speaking in general terms, very, very general terms right now, because I think the general principles are most important, and B, I'm really not the guy to talk to about the specifics. I don't spend my time studying CPUs. I would like to, because they're interesting. I just don't have the time to do that. You know. So there's that. That's another reason to organize like memory with like memory, because you know what you're talking about when you're trying to design a multi-core system, right? And then this is another reason why this whole idea, you know, people ask like, hey, are you gonna, in your programming language, put in some of these things like language level threads that get automatically scheduled and dispatched into, you know, hardware threads or whatever? And I'm like, no, because I mean, I never liked that kind of thing that much, really. Maybe that's a personal style thing, but I think also going into the future, that is less and less of a performance thing to do, because the details of who is reading and who is writing start to matter, especially more as you have more cores in your system. And in general, as you try to utilize more cores, it's just a harder and harder problem anyway. Okay, now the other reason, and this reason actually goes back further in history to have separate heaps and organize your stuff, is because you have these things called fragmentation, right? Which means it takes more, when you have an arbitrary data structure like a heap and you're requesting stuff from it all the time, it takes more memory than you wish it did to use the amount of memory that you're actually using. This is actually, with the milk and honey, it's drinkable. It's not the most delicious, but actually, so I would give this tea without the milk and honey 4 out of 10. Despite the fact that it's Golden Monkey. With the milk and honey, 6.5 out of 10. Okay, let's write this down in our tea buffer, tea scores. All right, so this is Golden Moon tea. One, its lowercase is sweetest black teas crafted with golden tea tips. That doesn't fucking make any sense. Straight. Don't tell me that's a microaggression to say that. 4 out of 10. Milk and honey, 6.5 out of 10. Anyway, what was I saying? Oh, yeah. So you have this thing called fragmentation. That means that you use more memory than you would like to use. And there's two kinds. You can call them external and internal fragmentation, right? So internal fragmentation is let's just say there's actually multiple kinds of internal fragmentation, right? So like if you have a data structure in C or C++ and it's got some members and there's holes inside the data structure for alignment purposes, that's even internal fragmentation because there are bytes in there that are trash that you're not using, right? But then also in a memory allocation algorithm, it will usually, like if you say malloc of 37 bytes, it probably mallocs more than 37 bytes, right? Because, you know, maybe it wants, because when you're trying to fit a lot of things into some space, it's really annoying if you're trying to do that at 1 byte resolution, right? And so usually people don't do that. Usually it's a bigger chunk size. And also for alignment purposes, like malloc, I think is spec'd to return things at 16 byte alignment now or something. I don't know. In general, a malloc will return you things at 8 or 16 byte alignment. By the way, that's a thing you could tweak on a heap. I mean, you can, if you want alignment, you can also allocate more than you need and then round up the base pointer, right? But that's also fragmentation, right? So, so the allocation algorithm is going to round your malloc up to like 40 bytes or 48, like whatever alignment that it wants in order to feel like it can service allocation requests efficiently. And then there's a thing called external fragmentation, which is just, let's say you ask for a bigger amount. Like I want, you know, 2,000 bytes of memory, right? So the heap algorithm, let's not say heap algorithm, the allocation algorithm's job is to go quickly find a good place to put that 2,000 bytes, right? And give you back that memory. And well, what if it feels like the best place to put it is a thing, there's a hole where there's, you know, 2,037 bytes free. I use the number 37 again. 2,055 bytes free, right? So it gives you that back. It gives you your 2,000 bytes out of that. And now there's 55 bytes on the end that aren't being used. Actually, 2056, let's say it's is that a multiple of 8? Yeah, it is. Because we were just saying it's aligned. So it wouldn't be 2055. But the point being, it gives you this 2,000 bytes, and now there's this 56 byte chunk sitting there that's like probably too small for most of the allocation requests you're going to make. And so it's just like a hole in the memory that you may never use, right? And if you just sort of draw on a piece of paper what it looks like when you start allocating and freeing things, it's very easy to end up with a bunch of tiny holes between all the stuff that you use. And that's called external fragmentation. Now, over time, in a heap like that, you can expect fragmentation to increase, right? In the beginning, it's like entropy. Things get messier, right? In the beginning, you start out, you don't have any fragmentation by definition, right? Because there's nothing there. And then you allocate things, or no external fragmentation. You allocate things, and then it's as you free things and put new things in the holes that are a little smaller, because they're always going to be a little smaller or the same size. They never can be bigger because that doesn't make any sense, right? So the number of holes increases over time. And so if you're running in a fixed memory system, for example, on the Xbox 360, when I ran Braid there, I was having problems when I had a single global heap initially because I would allocate a bunch of stuff for a level, go to the next level, allocate a bunch of stuff, go to the next level, allocate a bunch of stuff. And especially with all this rewind data and things, eventually, even though I knew that every level was within a certain memory footprint of actual memory use, I would run out of memory sometimes because the fragmentation would be too high, right? So now, if you have, and I did this actually in Braid, I used DL-malloc in Braid on all platforms, but I did it explicitly for the Xbox 360 because in, DL-malloc or most modern mallocs let you instantiate separate heaps. And so for a particular level, for the rewind data for that level, let's say, you make a separate heap. Anytime you allocate things, it comes from that heap, right? And then when you unload the level because you've gone to a next level, you can release that entire heap. And what does that do? It brings your fragmentation back to 0. You're starting with a fresh heap for the next level. So you don't have to deal with, any holes or anything, right? And you don't have to deal with even if you free everything, you don't know what that underlying algorithm is doing. You don't know if it understands that it's completely fresh. So just deinitialize the entire heap. Easy clap, right? And then you just go to the next level and you initialize it, and it just helps you keep things much cleaner. There's also bookkeeping. Yeah, I skipped that part, right? So allocation algorithms are not magic. They need to store some kind of data structure to help them find the regions of memory, and that takes space as well, right? So for all these reasons, you get less memory than you wished. And, here's the thing. For a lot of those algorithms, depending on the implementation, this metadata about how big is this chunk of memory and whatever that we've given, when you say free of a pointer in the C API, you don't tell it how big the thing is that you're freeing, right? So the malloc implementation has to remember that, has to remember how big that chunk was, and it has to somehow be able to find that data quickly from just the pointer to the base of the memory. And if you've never implemented one of these, you don't think about it. It's just, oh yeah, of course, free that memory. But just think for a minute about what you have to do to free that memory given the base pointer, right? That requires some data. A lot of algorithms, certainly in the older days, I don't know about now, put that data, let's say, right before the pointer they return to you. So, in, let's say, the 8 or 16 bytes before the pointer they return to you is some kind of back pointer to which heap this is from even, and then some other data to help you find a record that talks about the length and whatever, or maybe the length is stored directly there, whatever, right? So, well, when you read from that pointer, that data is probably going in your cache. Well, if it's right before, depending on alignment, maybe not, right? But that's also polluting your cache if you have a lot of small heap allocations, right? And people don't think about this. Now, there's other reasons not to put it right there. Because, for example, one common mistake that systems programs, is they'll overwrite memory, right? They'll start at some location and they'll memset or something, and they'll memset too far, and then you trash that bookkeeping entry for the next piece of storage after yours, right? And then next time you malloc and it looks at that, it crashes or something bad happens, right? Or you free that thing and it frees the long length, whatever. Very implementation dependent what happens. If you store that data completely elsewhere, that is not likely to happen. What's more likely to happen is that the user trashes their own data, but that the malloc algorithm doesn't crash. So that's more robust, but you also have to think about speed and all these things, right? Are we moving away from OpenGL and single core? What? What are you even talking about? Okay. How does a separate heap compare to allocating a bunch of memory yourself and creating your own allocator that manages that big chunk? Well, again, when we say separate heap and you say create your own allocator, you're basically, if you use it like a heap, you're basically implementing a heap, right? Like, if you don't use it like a heap, then that's actually probably better. Like, here's the thing, right? A heap is, and again, we're not talking about the data structure heap. We're talking about the usage, the colloquial usage of the term heap in systems programming, right? It's sort of the slowest, most, it's actually, okay, never mind. Garbage collected memory is the slowest, most expensive kind of memory allocation. But like, allocating things from a heap is very slow, right? If you're looking at a C program and it's full of mallocs, or a C++ program and it's full of news, which most of them are, it's probably a pretty slow program. All right. And this is the thing that most programmers don't understand, right? And so it's better if you find a way not to do that. But most programs need to do some of that, right? I probably do a lot more of it than Casey, right? My policy is I'll use the heap heavily and clean it up later. And I think Casey, for example, just doesn't like the smell of going there to begin with. So it's a difference in style, but you know, the camera's having a seizure. Sorry. Is it autofocusing in and out? I'll make myself smaller so it's less bad. Okay. We are officially done with T number 1 out of 5. That took an hour, so this doesn't bode well for the stream. But okay, T number 2. Special reserve tau of T. This one's also probably going to suck. Special reserve the art of T is universal. Okay. I'm going to go boil some new water. This will take a minute, and then we'll come back. Am I going to play Dark and Darker? No, I had a trash time with that game. Okay, this one did not come in a vacuum pack bag. Also doesn't smell that strong. To use the same AST data structure for both parsing and type checking, yes. I would like to move to a system where the parsed data is stored separately and then the type checking data is kind of layered on top of that. I just don't know how to do that without being too expensive. All right, let me start the water boiling. I'll be back. Okay, I'm going to have some albino strawberry palate cleanser while the tea boils. During the Q&A, you talked about how all the build settings environment of a program should be part of the program. How are modules libraries handled? So simply each library contains their own build information. I mean, what build information do you think you need? Like, you shouldn't be making a module that needs to load like weird Linux files or whatever. That's just not the way to make robust software. So like what even would you have? Do those teas have natural flavoring added? You know, we should check this for each one. Although I don't know if they're required to say that on the ingredients. For that last one, it sure didn't seem like it. I don't generally like flavored tea. This one also says ingredients black tea leaves, so they don't seem to have stuff added. How exactly do virtual alloc and heap alloc differ? I've never used heap alloc. That sounds to me like it uses a Windows heap implementation, which I've never used. Do I have electric kettle? Yes. Electric kettles in the US are not as good as European ones because we are on wimpy 110 volt power, so it takes longer to do things. In my vision, what makes a good software engineer? Someone who can get a lot of things done that are robust and efficient and maintainable. And you know this has happened because functionality increases. Somebody who sits around programming all day, if they can't make new things happen, or make things happen more efficiently or more robustly, if you don't see the change that they are making, are they a good software engineer? Like, what are they actually doing? And the problem is almost everybody at, like, you know, Facebook or used to be Twitter or Google or whatever, you can't tell that they even work there, right? Okay, guys, this might be a party foul and a little bit unfair, but I just realized that last time I did not wash the tea prior to steeping it. Washing the tea just means you give it a rinse in the pot right before. Okay, so we're going to do that this time. Heaping spoonful once again. Red card. Oh, it's a yellow card. Okay. Special Reserve Golden Monkey. Washing the tea first. And now the pour. And we set the timer. Tim Apple, the timer. 5 minutes, 15 seconds. If I were forced to watch one team sport, what would I choose? Like something where stuff actually happens at a reasonable pace. I mean, what qualifies as a team sport? How far can I stretch it? I mean, if I think actual sports, like volleyball or something, or like tennis, because like stuff is actually happening the whole time. Football, no. American football, no. American football is very boring. Yeah, I would watch Dead or Alive beach volleyball. Soccer is really boring. Yeah, it's pretty boring. Could watch chess boxing. Anyway, did we say everything there was to say about heap allocation? The point of all this is, here's the thing, and I've said this before, but I'll say it again, maybe differently or more clearly, right? Most of the programming languages we're using now were designed in the 90s. And the idea in the 90s was computers were just going to keep getting faster. And the job is to subtract thinking about details so the programmer can just make things work. And yeah, it's a little bit less efficient, but that doesn't matter because computers are just getting faster and faster, right? Okay, well, computers mostly stopped getting faster except for having more cores. So and the other problem that was not totally acknowledged in the 90s, some people knew about this, I'll get to this in a second, but in the mainstream understanding of computers, people didn't see coming up that there was going to be this issue that memory was going to be a lot slower than instructions. And so if you believed in the 90s, if you foresaw in the 90s that it was going to take 500 cycles to read from main memory, and in that time you could do 500 4x4 matrix vector multiplies, you wouldn't say that garbage collection is the future, because garbage collection involves hell of a lot of reads from main memory to even figure out what memory you're using, right? So that wasn't the view. The view back then was that garbage collection, yeah, it still costs a little bit, but it's fine. It's going to get magically faster and everything will be better. And that's not what happened, right? Had you foreseen this, we wouldn't have designed all these languages to be garbage collected, I don't think. Now, I got nothing wrong with garbage collected languages. I think it's fine that they exist. For a certain class of programmer, it's the right thing. But if you do that, you just have to be honest about how much you are paying for that service of having your garbage collected, right? That's all. It's quite a lot, but sometimes for some applications and some classes of programmer, it is the right trade-off to pay that much, right? It's just you can't ever expect those programs to be as fast as programs that don't do that. Yeah, it's true. All these 90s languages that people use are now getting type checkers bolted onto the top. But the problem is, of course, that's not as good as if the language were built to be statically typed, right? And so eventually we'll get around all this. Some classes of programmers, the horse is getting taller, question mark. I don't know what that means. Will you please be more explicit about your comment? I don't know what the horse getting taller. Is that some New Zealand euphemism? Okay. So I'm pouring the tea. All right. I'm going to get an initial sip. You know, this one is slightly better than the other one. I don't love it. This one says best by December 31st, 2023. How much water do I pour for 1 teaspoon? I don't know how much is a teaspoon or whatever. I just, for any particular tea I'm drinking, I just figure it out over a little bit how much tea I like, etc. I may be, okay, one caveat about this competition. It is possible, well, I'll just say I like my black tea relatively strong, right? And so the danger of having it relatively strong is that if it's not that good of tea, it's going to be more bitter and more nasty when you make it stronger, right? Do I use reverse osmosis filtered water? I use a Berkey filter with giant charcoal filters. You like green tea more? Well, that is your choice. That is your choice. Isn't it bitter if you steep too long? Well, everything will get more bitter if you steep it too long. Yeah. Like if you steep it too long, you sort of get to the core of the leaf or whatever. But we're not, right? Like we steeped it for 5 minutes, which is a little bit longer. Most of these things recommend 4. But in my experience, I like it a little more steeped, right? We're not going for subtle golden monkey flavor here. Are we programming at all? Well, I thought we were going to program, but my brain wasn't in a programming mood today because I gave it a rest yesterday. I did some firearm stuff. I need to get a new AR-15 stock. Does anyone have a recommendation for what's good? So my brain just isn't in the programming place right now. And I want to maybe let it rest a little bit, so I'm not going to push it. Magpul makes okay stuff. Broke the last stock. So I had this California legal Hera stock. It's the one that makes it look like a P90, and I had that on it because that's just what was on there when I bought it. And I just don't like that stock. It's not length adjustable, and I bought some extensions for it. Like, it was a little too short, and I bought some extensions for it, but the screws weren't the right length. And like, I'd rather just get a regular telescoping stock, since those are legal in most states that are not start with the letter C. So, and then I had one in a box that I thought was good. But it was actually, because I bought it a long time ago and forgot what I bought. That one was actually a combo stock and buffer tube, because I was like, I got some 80% lowers in case shit ever goes down. And I was like, okay, I have enough parts to make something, right? The thing is, I could take the buffer tube assembly off this one, but I don't want to, because it's the one that came with it. So like, maybe it's tuned, like the spring and the chamber size and all that are tuned for each other or something. I don't want to end up with like a massively overgassed or undergassed situation. Although this rifle was kind of overgassed. Like, it throws casings, man. But I just don't want to make things bad, right? So I want to leave the buffer tube I have. So I just want to get a regular stock to put on there. You're not supposed to say 80% lowers. You also overgas sometimes. Yes, that's a problem that many people have. Anyway, maybe I'll just get whatever they have at a store and try it out. Big fan of Magpul CTR. Yeah, those are pretty common. Like, I think most stores I would go into around here would have a Magpul CTR, so pretty easy. Yeah, I'll try that out. I also have a problem that I can't, you know, I bought an angled foregrip, and I can't put it on because this thing slides onto the pick rail. You'll recognize it. PUBG players will recognize this shape. This slides onto the pick rail, and it's being blocked by a smaller pick rail I put up front for a bipod. And the problem is that section of pick rail I bought off Amazon, and it has cheap Chinese screws, and the screws got stripped even though I merely tightened them by hand with a screwdriver because they're made out of cheap-ass soft metal. And they're recessed, so I can't really get them out without specialized screw extraction tools that I don't frickin' have. So I'm just going to have a gunsmith look at that. Drill through them. Yeah, it's messy. Like, I don't have a garage. I live in an apartment building, right? And so getting little shards of screw metal flying around the room, it's just not good. Anyway, okay, it's time to proceed to the milk and honey phase. For tea number 2, the Tao of Tea. Am I collecting guns? Not really. I mean, I'm not Landmark, if that's what you're asking. Is bitterness the only downside of steeping too long? I don't know. I don't know, man. Okay. We've got milk and honey. You know, it's okay. Get a screw extractor set. Yeah, but like... I just would rather not have to deal with it. I don't know. How does the default runtime support assertion failed call abort? I mean, so this debug break function is what it calls at the end, right? And this, so if it's runtime, which is probably what you're talking about, we just throw an int3, which is the standard thing you do on an x86, right? If it's compile time, we actually do this, which will break into, there's like a bytecode debugger built into the compiler, and it'll break into that if you're running with that option. Otherwise, you know, it'll tell the compiler to exit. Put a rubber band between the screwdriver tip and screw head. I mean, these are really small screws is the problem too. They're like the little like star style screws. And it's a pretty small, yeah, I don't know. I could maybe try that, but it doesn't seem likely to work. Okay, verdict on this tea. Straight, 5.3 out of 10. Milk and honey. We should line these up. We obviously need more significant digits. Milk and honey. Okay, this is going to be shocking. .0 out of 10. It's actually lower than the Golden Moon with milk and honey. Because it's just kind of a blah. I want to savor and enjoy my Golden Monkey. The thing is, the Golden Moon tea was kind of nasty and bitter straight, but once you add the milk and honey, it has a little bit more punch. This one is just kind of flat. You're dividing a float by an integer. No, according to the semantics of the programming language, this gets upcast to float. Justice for Golden Moon, it wasn't rinsed. Hashtag rigged. What milk am I using? The milk from Publix. I think it's like Horizon milk. It is... you know, regular fat milk. It's not craziness. It's not like some kind of almond milk like Casey would use. Okay, third tea. We're not going to start it yet, but third tea will be Master's Collection from Tea Bloom Golden Monkey. Oh, you know, people were complaining about font size the other day. Here we go. Slight Glee, malty flavor. This is what they say. This is not what I have to say about it. This is the propaganda from the tea company. Okay. Yeah, I end up getting rid of a lot of tea that I buy because I just don't drink it fast enough. I had to stop my Tea Runners subscription because I'm drowning in Tea Runners tea. Oh my God, so much Tea Runners tea. Okay, on the one hand, the smell of this is not very strong. On the other hand, it doesn't really smell dry like the other ones did. Like this one smells better to me, even though it barely smells. Okay, we're going to give it a little bit of a break. We're going to do some palate cleansing again with the albino strawberries. Okay, what technical topic do we talk about for this next tea? Who has a topic for us? A steam sale is not a technical topic. What happens after these things are released, I don't know. I mean, there's other games that I want to work on that are sort of in the backlog. But I don't want to predict specifics because who knows? Who knows? Like a lot of things depend on how well a game does, right? So before The Witness came out, I was like, maybe I'm going to have to shut down the game company, right? If it doesn't sell enough copies. And I was fully ready to do that. And we didn't have to. Because the game sold very well. Much better than I expected. But it's a similar situation every time. Like, I don't know who's going to buy this new game. Feasibility of auto-vectorization. I mean, that's not really my area of expertise. I think you will find that compiler authors are in favor of auto-vectorization because they do demonstrably get improved performance on programs with it. However, the amount of performance increase is not particularly that high, right? Because it's hard to auto-vectorize efficiently. So it's, I don't know, it's like 10% just to pull a random number out of the air. On code that's amenable to auto-vectorization. That's not, you know, auto-vectors or vector instructions are not designed for 10% increase. They're designed for 4x, 8x increase. So compilers are falling woefully short of the potential. And I think to achieve the potential of those instructions, you just have to do it yourself. It's not a surprise. It's like every other performance thing. Direct storage, yay or nay? Have I ever thought of getting an Epic Mega Grant? Direct storage, yay or nay? I haven't looked at the specific API, but that class of API of having a more modern way to talk about files, I think is absolutely useful and helpful. I just don't know the details of the direct storage API. Have I ever thought of getting an Epic Mega Grant? I mean, I don't feel like we're the class of developer that's intended for. Like The amount of money that those are, as far as I know, is just not that much relative to our burn. Who knows? I mean, if there's an epic mega grant for $2 million, that would be awesome. But I don't feel like that's what they are, usually. Have I seen the talk on Verse? I haven't seen it, no. OOP versus data-oriented engine design. Which one is better data-oriented? Repeat bitfield question. I use bitfields a lot to store small integers. You implemented a BVH for culling, and you were able to pack a lot of values into a few U32s. That was a nice perf improvement because BVH nodes can be fit into each line. BVH packing was done on CPU using C-style bitfields, and it was easy. Traversal was done using HLSO, which doesn't support bitfields, which made unpacking all the values quite hard. Well, it's not that big. See, here's the thing. Okay. Yes, packing more values into less memory is often helpful for the reasons that we previously discussed, right? When I need to do that, though, like I just shift and mask anyway. Like I just never used bit fields. They weren't that appealing to me. And shifting and masking is not that big of a deal because you just make a getter and a setter for your values and you don't think about it, right? And you just put in, for each one of those getters and setters, you put in the constant for how many bits it is, and then you have all these defines that like do the shift and mask. Now, if I had to do a super ton of that, it probably would be more annoying than bit fields. But usually I don't have to do a super ton of that. Usually I have to do a little bit of it. But yeah, I don't know. Like I said, it's not like bit fields are off the table for the new programming language. It's just hasn't been a priority to me. All right, I'm going to start. Did we get rated? What? Who's? Oh, hello. That's why. Hello, people. So we are doing. We're doing a T battle royale, except it's not a battle royale. It's a pageant. We're doing a T pageant today. We're about to start T number 3. They are all golden monkey teas. And we're also talking about technical topics in between. What about that A16Z grant for video game stuff? I never heard of such a thing. Epic gave a grant to Godot for $250K, Blender for 1.2 mil. Yeah, I mean, the difference between those projects and what I'm doing is that those projects are publicly released and are proven to be useful to a large number of people, right? This programming language is not at that stage yet. And so if I were giving out grants, I would just put it mentally into a different category. Okay, back in a second. Okay, the water for round 3 is now boiling. Are the light rays in Sokoban game rendered using BSP? No, it's like a ray casting in the shader kind of a deal. Ever had a third-party DLL change the settings of the FPU without telling you? Why, yes, that is why Braid on Steam was crashing. Because... Actually, no, that wasn't them changing the settings. It was the AMD driver dividing by 0. But, yeah, I wouldn't be surprised. Like, look, having global FPU settings is a bad idea. right? That is just not how things should work. It's a legacy of the x86 CPU that it works that way. Nobody would do that now, right? Like, what you really want is FPU flags per individual instruction, or if that's slow, you want a very cheap instruction that you can emit that changes them, that you do all the time, right? Like, just having global flags is kind of ass. In some languages, defer has runtime overhead. Does defer here have overhead as well? No. No. How do I implement it to avoid performance pitfalls other languages fell into? I don't know. You'd have to tell me what the particular pitfalls are that you're concerned about, because I don't know what those are. Did I hear about SPURV? What about it? SPURV for pervs? Is that what we're talking about? Okay. I meant the gameplay light beams that are powered by the gems. Oh, those. Yeah, so those were BSP trees originally. Not exactly to render them, because we rendered them just by outputting polygons, but forming them. And the reason was so they could bounce off stuff and be partially occluded. But, you know, I gave it to somebody else to work on, and it was re-implemented as something that's not BSP, and it looks mostly fine. We just need to, you know, tweak some stuff about the behavior. Do I plan for the language to ever get to a point when it's done? I plan for it to get to a 1.0. The A16Z fund is 600 million. They might give you a little 2 million. Yeah, but like, no. See, venture capital is a whole different thing. It means they take ownership in the endeavor, right? And when you sign up for that kind of thing, you are representing to them that you're on a certain kind of path of growth and revenue generation that I am not on intentionally. And so we would not go to VCs to seek funding for things. That's just a different thing. Go has a defer that always runs the end of function in LIFO order, but for some reason it's slower than adding those defers before the return. I don't know what that reason is. I couldn't tell you. I don't know enough about Go implementation details. For us, defer is totally static. So the implementation is we literally just output the instructions before the return, the same as if you type them manually. So it's just exactly the same speed as if you put those instructions manually. So I don't know what they would be doing that would make that different. When you're dealing with a multi-threading problem, how do you start approaching it? Let me get the water. Okay, we're going to remember to rinse the tea this time. By the way, here is the plate of the used teas. Okay. Here we go. Tea Bloom Masters Collection. Let me get, there's a little bit of the old tea leaves in here. We got to get those out. Heaping spoon of, wow. You know, I like this one more already. It's like a looser with more goldens. I have a good feeling about this, but we'll see. We'll see. All right. Now, I'm going to rinse the tea. Okay. Pouring out the rinse. Pouring in the real water. And we start the timer on the phone from Tim Apple. Boom. 5 minutes. Oh, you're asking me if I heard of what SPERV is. Yes. Yes, we all know about that. Anyone have any idea why game developers put up with the mess that is OpenGL, Vulkan, Metal, DirectX 12, and all the problems with day one drivers? The problem is, at the end of the day, that if you're a game programmer, your job is to make a good game, right? And in the old days, when games were smaller and the underlying systems were simpler, it meant you could work with the system more directly and tweak things and re-implement things, right? Now, everybody has to deal with such big and complicated systems. They don't have any time to question things or think about changing them or even to understand the system they're working with, really. Like, nobody does, or few people do. So like, there just isn't time to fucking do anything because we're drowning in dealing with all this stuff. So for somebody like me to take all this time and say, I'm going to spend half my time working on this programming language. Oh, dude, my cake has a Trigicon SRO on it for some reason because I shoved it. Yeah. Okay. So it's just very unusual because nobody feels like they have the time. And the observation that I made back in 2014, a long ass time ago, that made me want to start down this road was, yes, I'm drowning in all these problems, but the reason I'm drowning in all these problems is the decisions we made in the past. So we're just going to continue to drown in these problems ever more unless we start making decisions differently, right? When most people have not made decisions differently, and things have been getting worse, just like I thought they would. And I mean, COVID also added to that, to the point where we have these AAA games coming out that are obviously like barely anything happened. So like the new Battlefield, the new COD, the new Overwatch, like those games barely got worked on in real terms. Like lots of people spent lots of hours supposedly working on the game, but most of those hours did not produce anything useful. Part of that's work from home, but part of it is just that's where we are today in terms of our technical systems and all the crap we have to deal with to do anything. So nobody feels empowered to fix anything because everything is too big and too horrible. And then also, yeah, I mean, so part of the problem is, what are you going to do if you don't like the situation with shading languages, for example, because you don't, right? What the thing you would have done in the old days is just make a shading language and make it run everywhere, and then maybe people will use that. You can't do that now, in part because everything is so complicated. Making a shading language even work on one GPU is almost impossible, in part because most of the information is proprietary, and in part because it's so much more complicated. So making the equivalent of C, but for shaders today, is at least perceived to be impossible for even a group of people to do, let alone one person, right? And so we're just in a very horrible place. And that's why things are the way they are. GPUs have vastly different ISAs. So did CPUs back when C was made. That is not an excuse. It is not an excuse. It's much easier to implement support for DX12 Vulkan Metal than support for every vendor and GPU generation combo. That is an excuse. Dude, CPUs in the past didn't even support the same kind of integers. They had totally different representations for floating point numbers if they had them at all. They stored strings in different ways, and yet we still made programming languages that ran across these CPUs. It's not that hard. What you're saying, you're repeating propaganda. Why does this propaganda exist? It's because the makers of GPUs want to stand between you and their hardware. They want more of a vertical control over the system. That is why we are in the situation that we are. If there were an open source GPU, imagine somehow that there were an open source GPU that was like community owned, which I'm not philosophically arguing for this because I don't think it's possible, but imagine it were community owned and there were no trade secrets and it was just as fast as an RTX 4090, right? People would have no problem making programming languages for it. And if there were 3 of them that had different architectures, people would have no problem making programming languages for them. The reason we can't do it is because NVIDIA, AMD, and Intel don't want us to do it. That is why. That is the reason. And then also because they're so complicated that we would need massive amounts of help anyway. They want to be in control of what languages run on their thing, and that's why we're in such a mess. Cake is a really good palate cleanser, guys. I don't know why people don't have cake more often. Is the compiler going to be made public this year? Given that the year ends in less than 10 days, no. No. Like, again, people who repeat this reasoning that the GPU ISAs are too different have literally no idea what C ran on. Like, there were so many different computers. Dude, C ran on connection machines. It ran on VAXs. It ran on shitty home computers. It ran on everything. What's an ISA? Instruction set architecture. It's like the interface language that the CPU speaks that you tell it what you want it to do. Oh, guys. Oh, okay. Honestly, so for control purposes, you know what? I should have a strawberry first, because that's the uniform palate cleanser. The cake going into this may be making it taste better, but so far I like this one a lot better than the other ones. And if it were up to me and we didn't have a controlled steeping time for this experiment, I would steep this one longer than 5 minutes because I want even more flavor of the golden monkey flavor that I'm getting. Yeah, the real reason there isn't a uniform shading language is that all these GPU vendors see their shading language or their, you know, it varies depending on who you're talking about, right? So now it's more about compute languages being proprietary, right? Because they want to get in on the neural network stuff and all that. But so like so there's operating system vendors want a piece of the pie. So they have their own. So you have like metal shading language, which Apple wants to use to lock you into Apple operating systems, right? HLSL, Microsoft wants to use that to lock you into Microsoft operating systems and so forth. And then you have GPU vendors who on the back end, they see their driver for HLSL and, you know, Vulkan and Metal and whatever as being a competitive advantage for them because they invest resources into it and all that, right? And it's stupid. Like you... It's interesting because we saw something like this in the past. So like back in the workstation days, people who made these computers had their own C compiler usually, right? And they saw it as a competitive advantage. But eventually now we have Clang and GCC and all this stuff that are generally better than how those compilers were in the past. You still have some proprietary compilers. So for example, Intel still makes a C compiler. Nobody really uses it though, except in very specialized cases as far as I know. Is there a good faith rationale for Metal's existence? I mean, look, here's the thing. In a sense, there's a good faith rationale for any programming language's existence, right? Because you need it to be possible to have new ways to try to do things better. That's how things improve. So you shouldn't ever say, hey, we should lock down all the shading languages. We don't need any more. No, right? But if you think Metal is a better shading language, let us use it on any GPU that we want, on any operating system that we want, right? And then people will use it if it's better. But that's not how it is, right? You can only use it on Apple operating systems. Intel's is Intel's LLVM branch, basically. Yeah, I mean, their C compiler went way back in time before LLVM was a thing, but it's probably a completely different compiler now, right? Yeah, okay. It's time to decide on the straight T score for this T. I have two scores in my head, and I'm vacillating between which one I'm going to give it. This is difficult. Okay, milk and honey time. We might have to renormalize these scores on the end. The other score in my head was 8.3. And the reason I didn't give it 8.3 was I was like, I want to leave room for appreciating the other T's if I like them even more, right? So I'm picking 7.9 to give more headroom, but it could be an 8.3. It's a lot better than the previous two T's, is what I'm going to say. Just give it an 8.3. Let's say maybe 8.3. All right, so the honey is now in. And the milk is going in. Very nice. Okay, so the previous 2 teas, after this is over, I am dumping those teas. This one I would keep. Okay. I have an opinion, but I'm going to palate cleanse again for a second. I'm not going to palate cleanse with cake this time because I don't want to give it too much of a competitive advantage. These are all Golden Monkey teas. Let me make that clear. Is it a standoff? I don't know what it is. I mean, milk and honey makes everything better. Actually, I might mark, this is a little too high. It's 8.3. 8.3 for sure with the milk and honey. I would drink this all the time and I would not be sad. I think I would score this higher if I steeped it longer. Maybe I should drink milk and honey. Well, that's logical. I think if I bumped the straight up, I would bump the milk and honey up too, because the milk and honey is better than the straight. Like, let's not get fancy. What is a tea to milk ratio? I mean, there's not that much milk. It's, you know, like I think if you put a ton of milk in, you're drinking milk, you know? So it's like, I don't know if you could see this amount of milk. That's probably about how much it is. Maybe a little less than this even. It's hard because the milk is kind of going up the glass on the side, but not very much. Okay, we need a new technical topic for tea number 4. Cold or warm milk? Well, I mean, I took it out of the refrigerator, but it's been warming over the past hour. What do I think about game developers starting doing their own hardware? I don't know. It's not a thing that I am that into, but I understand why some people would think it's cool and fun. It's just never been my thing. Like if I were to make a new CPU or a new hardware of some kind, the goal of it would be to, again, try to clean up the mess of our current computing systems, right? So that is where I would be at. Three. Is there anything someone not working for AMD NVIDIA can do about the current GPU disaster? I honestly don't know. I honestly don't know. I feel like what's going to happen is the hype will all go into AI accelerators, and these companies will be more about targeting that kind of a thing. And so maybe they'll still make GPUs as a separate product line. Maybe not. But like, I mean, you'd have to ask NVIDIA what their long-term plans are, right? But the thing is, architecturally, an AI accelerator is a bit different from a GPU. So the thing I'm thinking is, if a lot of the hype cycle moves into AI accelerators, maybe GPUs will stop arbitrarily changing as fast as they currently are. And that means maybe it's feasible for a well-funded third party to come along and like make a language targeting them. Because you have to reverse engineer all this shit and whatever. And the thing is, you know, back in the day to make C, you didn't need to be well-funded, right? And now you do. And it's like, ugh. Is risk V a step in the right direction? Relative to what? What problem do you envision risk V as solving? First Golden Monkey tea you bought was really good, but they were sold out when you went to get more, and the other kind you got is still good, but not as good. You know, I feel your pain. Wasn't that a theme of Sean's stream the other day? Which Sean? Which Sean, and is the VOD up? Link me the VOD so I could watch it. Yeah, I mean, definitely on the game side, we kind of just want to do more compute anyway. Like, we want to fill pixels, of course. But those pixels are filled as a result of arbitrary compute, which of course it is, right? Like, that's all we ever wanted to do was write a program. And before GPUs came along, we wrote a program that did a bunch of arbitrary compute and then filled pixels. And so it's no surprise that we want to do even more of that as scenes are more complicated, right? Oh, cool. I didn't know Sean was still streaming these days. For some reason, I thought he was... Okay, tea number 4. In the tea contestants. We have done the 3 in canisters. We now move on to the big bags OT. This is now Tea Lyra, the galaxy of teas. Okay. Number 4, and it's stylishly lowercase. Tea Lyra. Look at the attitude. Imperial Golden Monkey. Do they have a catchphrase? coupon is valid on our website, tlira.com only. That's not encouraging. Tea makes everything better. Okay. Thanks, Mom. Okay. We're going to open it. Oh, this one's very different, guys. Wow. So these are like mostly gold strands. And they're like straight. They're like long and straight like banana slugs. Like the previous teas. Let me show you. Any of these previous teas. Okay, guys. This Tao of tea had a little lid on it with a cap, and I just pulled the cap and it broke. So obviously it is made by the same people who made my shit-ass Picatinny rail that's stuck on the upper now. So this whole tea is gone. I can't open it. All right. Out of the running. I mean, we already had judged that one. Okay, but so for example, to go back to this one, it's like much smaller, curlier. I'm not going to say it, but you know. And then these ones are big ass banana slugs. Don't waste it. We already decided it was undrinkable. Not undrinkable, but it's below the threshold for keeping. Okay. So I'm going to go boil some more water. Why don't I make my own tea? I've just got too much else going on. Okay. New technical topic. The water is now boiling. Getting the remainder leaves out of the previous one. What project gives me the most respect for someone? I don't think it's a specific topic. It's just how impressive is what that person does. And the problem is almost nothing that any programmer does today is impressive because we're just in an environment where it's very hard to do things that are impressive because everything is so complicated and messed up. But also, we just don't have a culture of that anymore. So the rest of the world seems to follow the US when it comes to programming because we're like the most successful at it for some reason. And part of that, I believe, is down to we have a little bit more individualism here, right? And programming is at some level an individual effort. Like, of course, you have to collaborate with people to make big things. But, you know, a lot of it is just like, how well do you do when you sit down and start typing? And we're losing that. Like, the culture war is trying to turn us into a more collectivist society. And I think that's bad for programming, because the things you're forced to believe when you're being propagandized into being a collectivist are, you know, one person can't really make that much of a difference because it's about the, you know, the community or whatever. And like, not really. That's not how computers are exactly. So, but if you believe that, you'll never try. So I don't know. I don't know, man. We're losing our ability to do these things. What workloads seem good to offload to GPU but are actually awful? I mean, I don't know. Everything is awful to offload to GPU. I don't know what you mean. Will we zero structs on declaration? I mean, yes, we do that already. That's how it works. People here are just pretentious jerks who make their own crappy engine. They will never make anything impressive. Wow, you know everything about 900 people. You know literally everything. Account created yesterday. Okay, normally I wouldn't ban you if you were a real account, but it's obviously a troll account. So, an account created yesterday that shows up and just starts spewing stuff like that is not, that's just not a thing. Jessica Max game looks impressive. Yeah, I think so. I'm looking forward to when it's done. To think I almost didn't ban that account. Snap pixels to a grid in a 2D game or no. This makes it look horrible in Aliased if you do that. Okay, we need a new technical topic, guys. Let me get the water. We've got the water. It has just been boiling, so I've opened the lid. Now, I'm not sure how much tea to put in, because the packing of this tea is so much different. It's much more airy. So like, here's kind of a heaping spoon, and I think we just need more than that. It says use 1 teaspoon of tea per 8 ounces of water, but like, although maybe, I don't know, guys. This is a moral choice, even more difficult than BioShock. Like, I'm just gonna put more in. If that's a mistake, then it's a mistake. I should apply for Twitter CEO. No. I think the projects I'm working on are important and do not wish to run a social media company. Like, I get jerks like harassing me all the time already, dude. Like, the last thing I need is to be in the epicenter of jerks harassing you, you know? All right, let's rinse the tea. Boom. Now we pour the water in. Okay. There we go. It is steeping. We got to start the timer so as not to be inaccurate. There we go. Tim Apple, thank you. I'm going to go get a little bit more milk because we've got 2 more teas to go. Using scripting languages for game logic prototyping, no, don't do it. I've explained at length why, and I'm pretty sure there's YouTube videos you could look up with me giving my full opinion on this, but the answer is no. Since when do I like tea? Well, for a long time, I've drank tea because I don't like coffee and I work in coffee shops. But probably, I mean, my taste in tea has certainly evolved a lot over time. Are there any pointer aliasing rules? No. A pointer is allowed to point at anything it wants. Do I think people 50 plus years old are going to live through a time of technical progress in computing as dramatic as that what we lived through from 1980 to 1990? Oh boy. I don't know. It all depends on, like, it all depends on where the chatbot thing goes. The problem with the current chatbot thing is because it doesn't really understand what it's doing. You can't rely on the output to be accurate or even, let's just say accurate, right? And so if you're trying to do any kind of problem solving, you need that. And so the question is, how hard is that? Did I ever consider moving to Batumi or Tbilisi? No. No, 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 no. No, 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 no. Like what we're seeing in AI right now could be a local maximum, or it could be the start of a lot of tremendous rapid progress. And I don't think anybody really knows which of those that it is. Are there any advantages to transforming an abstract syntax tree to a text-based human-readable assembly file and then loading that into an assembler to produce a binary? No, I don't think so, although that's the way a lot of compilers worked in the past. Especially on Unix systems, the assembler was like a different thing. That may still be the way GCC and Clang work, right? So like you do that if you put, I believe the option is -S, if I remember my Unix correctly. I don't know why it's dash capital S, but if you pass dash capital S, you get an assembly output of your program, right? And I believe that that's historically because that's how they would compile it, because Unix is all about piping crap to other crap, right? So I don't think that's a good way to do it, but it is how things were implemented. All right, that's our timer. We are going to pour the tea now, tea number 4 out of 5. Oh boy. Oh boy. I'm going to let the water cool a little bit before I try it. You have to reparse the assembly and it's a memory inefficient format. Both of those are true. However, parsing is really fast. That's not that big of a deal. What is a big deal is just even a round trip to disk and back. Like if you're trying to really be fast in compilation, you would never round trip to disk, right? We were talking earlier in the stream about how far away main memory is, right? The disk is way, way, way further than main memory, right? Now that said, your assembly files may stay in your operating system's disk cache. That's still mediated by the device driver and what, like you have to go through the kernel probably to get, like, it's a lot further away than main memory. And if you're compiling something that's 1,000 times bigger than it should be, like Clang, there's way too much stuff to ever fit in your. So I just said operating systems cache. What I mean by that is that's different from the CPU caches we were talking about, right? It's when you read and write files on Windows, the operating system itself keeps a cache that I think is dynamically sized. It basically, whatever RAM you're not actively using is used as file system cache. And then, you know, that goes down to some minimum or some minimum size. Because, you know, if a lot of people are reading the same file, it's just a lot faster just to have that data there for everybody to read. Did I have a chance to make any progress on the OS lecture I said I wanted to give? I'm not sure which one you mean. If you mean the one about simplifying the entire computing stack, here's the problem with that one, is that recently I've given 3 smaller, shorter talks over the past year, like 15-minute, 20-minute talks about like subsets of that. And they were some of the worst talks I ever gave. I thought the actual talks were fine, but the reception was very hostile and disbelieving. And like, who is this dumbass telling us that software isn't awesome? Like, people are very, very hostile to the idea that software isn't doing that well, right? Especially in Silicon Valley, right? That may have changed even toward the end of this year, because a lot of this reality is socially determined, right? So like everyone sees, oh, these companies are all doing great. They're having, you know, historically, the last time I gave one of these talks was like in February. You know, they're having historically high stock prices and stuff. So for most people, that just determines reality. So if you come up to them and say, software, the actual technology of software development is stagnant, they just look at you like you're a fucking idiot, right? And I've had very bad experiences with that. And so given that it's that difficult to talk about, to then go and do like the 3-hour speech that covers this sufficiently, just, I'm not sure how to do it in a way that it's actually going to work. Maybe it doesn't matter. Maybe the audience just has to be self-selected. But the other thing is I'm also just too busy. Are they on YouTube? No. It's probably a new generation you met there. I mean, at one of them, yeah, it was like kids who are all web programmers at Google and think they're badass for making, you know, 250K at Google. But another one of these had people who were names that you would recognize. Names that you would recognize, and still the reception was not good. So, I don't know. I don't know, man. Talk I wanted to give on how operating systems should be today? No, I've never said I want to give a talk like that. Okay, guys. You've recently started noticing that premature abstraction creates more problems than premature optimization. In my experience, does this hold up? Yes. Yes, premature abstraction is really bad, yes. I'd never phrased it that way, but that's potentially a powerful way to phrase it because people talk about premature optimization all the time. I think that's a very, very accurate observation. Okay, guys. Talked with some startup CEOs at a party and couldn't convince them that the scale of their tech problem was closer to one engineer than the 12 that they had. Well, yeah, I mean, you're just not like when everybody operates a certain way. Like everybody in that ecosystem is looking at how everybody else does things, right? And so they're just going to do things how everybody else does things. Oh, you like to interview with Luke Avery? I'm glad. I felt weird about it because I thought at the beginning we were going to talk more about complexity and the problems with it. And we ended up, I feel like I ended up not really saying anything new that I don't always say. And we didn't even get that deep into it, but maybe it seemed different to other people. Okay, guys. This tea looked really good and it smelled really good. The taste straight is a 6-7 out of 10. Now, I am shocked by this because Golden Monkey is one of my favorite teas. And yet, we're not hitting a score that's like high. So maybe we're getting unlucky here. Maybe my standards are too high. All right, milk and honey phase, begin. I do usually drink Golden Monkey with milk and honey, though. Like, that is a thing. It is how I do it. How do I rate the Tea Runners version? I don't know if I've ever had Tea Runners Golden Monkey. I mean, I should have had Kaylee send me some. I might actually have some. I've got so much tea runners, but I would have noticed if some golden monkey came in the mail. Do the heroes of Sokoban levels allow you to cycle backwards through the heroes? We have forward cycle on one key, and then there's a character wheel that's maybe more designed for gamepad select. And that's it. Although, who knows? Like, we might make RB, LB on gamepad go forward and backward. It's hard to say. It depends on, like, how many controls do we need for other things. Golden Monkey is also a beer. Dude, if I liked beer, I would try it. I would try it. I don't know if I would like it. Oh, dude. I just accidentally... Yeah. Do I believe in deliberate practice for programming? I don't know, man. I mean, for someone with my level of experience, I just have too many hard things to do. Like, sometimes, though, I could pick... So when you're programming a lot, right, it can just turn into this giant miasma of just, oh my God, there's so much to do, and I'm doing it for years and whatever. And so it can be very good to frequently isolate very specific things and be like, I'm going to do my own version of a sprint on this thing or whatever, but it's not accountable to anyone else except me, right? I'm doing it just to see how well I can execute it. Because I'm approaching it as a specific subtask, I can, you know, do a little bit of like extra deliberate thinking about how I'm going to go into it and planning and stuff and try to do a good job, right? And then just execute on that and then observe how well you did and judge your own performance, right? I think that for me is something that I do sometimes, you know, to greater or lesser degrees. But I don't really pick a random programming project out of nowhere and just sit down and do it. Why not? Because I just have too much to do, man. Like, it already takes so long to do the things that I do. I don't want it to take any longer. Now, Mike Acton, for example, I remember him some years ago saying publicly that practice was a good idea. So maybe he does it that way. But that has not really ever been a thing for me. I just work on what I want to work on. The other night I was using telemetry. Is it a good profiler in my opinion? Yeah, it is a good profiler. Does being bad at competitive programming mean you're a bad programmer? Not necessarily, but it's certainly correlated with being a bad programmer. It is certainly raises the question of whether you're a bad programmer overall. Or not you, but the hypothetical person in the subject of that question. Have I ever used an ORM in web programming? No, I haven't. I don't do web stuff. Anyone know how much a telemetry license for an individual is? I don't know. You'd have to ask Rad. I don't know if they're taking on new customers anymore. Maybe they are, maybe they're not. All right. I think we have another surprise upset. Yeah, here's the thing. So to the extent that these teas have some kind of like a little bit of nasty bitterness when straight, it makes them taste better with milk and honey. So the delta between these is a lot higher. Like, I don't like this one straight, but with milk and honey, it's not that far off this one. How did I survive before Braid? Well, for a few years, I was a consultant on video game programming and would go do programming contracts. Would Windows be acceptable as an OS if we replace the shell? Unfortunately, Windows is getting worse over time in terms of basically everything. So no. I don't really like languages like Java or Go, but do I think they've got at least some parts they got right? I mean, no language is 100% bad. So it's kind of a straw man question. Have I ever done anything in the realm of computer vision? A very long time ago, yes. I didn't work that hard on it relative to things I do today. So it never got that far along. Wow, I'm kind of feeling bloated from all the tea that I drank today. And I'm kind of tripping right now. Like I've got a huge buzz from caffeine that just hit. So I'm going to slow down a little bit before tea number 5. Tea number 5 is, as we've said in the beginning, it is the full chi golden monkey tea, which we think is the golden monkey tea that I usually get off Amazon. But it is in a different package now. And this makes me worry somewhat. Who knows if it's really the same tea? I'm opening the package. Oh, it smells better than these other teas. Now this one has a relatively low ratio. Unlike the previous one, which was these big open leaves, this one is again tight curled up leaves with not that many gold colored. Did I have a significant change in mindset that allowed me to tackle and finish Braid? Yeah, I decided I was getting old and it was time to stop fucking around and finish a game. Also, maybe because I was training Kung Fu at the same time, maybe not, but I had more discipline. Tulsi tea is quite good. I don't know. The Tulsi teas I've tried are nasty, dude. I mean, I like Tulsi Gabbard, but Tulsi teas, can't do them. Have you ever gotten good reception regarding software is bad from non-programmers? No. No, non-programmers also look at me like I'm crazy, but they also just don't care. They're like, why would I care about any of this? I mean, you know, the thing to realize is regular people in the world have no idea, for example, that video game, like if I say I'm a programmer and I program like compiler internals and video game engines, that is an incredibly different thing than somebody who makes like front ends of web pages in JavaScript and is all day like doing CSS to make the font the right size or whatever, right? To 99% of the world's population, at least, those are the same thing. And so you just can't, there's no conversation to have. Is there a book or two I could recommend to get you into game dev? Yes, the Bible or something, because if you're asking about a book, you don't have sufficient motivation to get into game development. You need motivation. Otherwise, you wouldn't be asking me. You would just be doing it. Go like watch an Andrew Tate video about being a man and being a top G or something. Top G, where G stands for Game Maker. That's right. Top Game Maker, who programs in Game Maker Studio Pro. The Bible by Andrew Tate. He should do that. Dude, that would be a bestseller. Can I roast your game? No. He's Muslim now. Oh, I didn't hear about that. Is he Muslim because he's allowed to have multiple wives that way, or what? What's the deal? I'm glad you like the videos. I mean, he could have been Mormon instead. Okay, I need more time before the last golden monkey, guys. Literally, it's like I'm on drugs right now. It is. Now, I'm thinking that that's from all the tea. Maybe it's just this one is very special and magical. But I feel like it's quantity over time. Anyway, of these teas, this is the main one I would keep so far. Full chi. Fruity taste, mild, smooth. I do not think of Golden Monkey as having a fruity taste at all. Not at all. All right. We're going to see how I feel about this. Maybe this is still the tea that I enjoy all the time. Maybe I'm going to enjoy it a lot less because it's cup number 5. You know what I'm saying? How many teas do we have? This is the last one. This is the last one. Yeah, I'm high on drugs. Let's talk for a second about what I'll maybe be working on later today after this. So this, I mentioned earlier in the stream, this is our base node for the syntax tree. It's just got a lot of crap in it. And what I'm working on right now, this here is a serial number that's unique per node. And it started out just as a debug mechanism, as a way for me to set breakpoints. But over time, I found, once this is here, you find reasons to use it to help you implement things. So there's a few things in the system that use this. For example, when you expand a macro, we record what this value was at the beginning and end of the macro. And then if we have an error message and we want to say what macro it's in, we have a record of all the macros we expanded, and we go back to it and search for this node by looking in those ranges. And if we didn't have this range, then it's much more precarious, because it's like, what do? Have a hash table of every single node that was in that macro expansion? That could be very expensive. So you need an alternate way of doing it. And I came up with an alternate way of doing it, but it's like, it's non-trivial. And so maybe today I'll try and do it and see if it works. But the point being, you know, I'm trying to get rid of this. And this would be 8 bytes off the base node if I can get rid of it. This one is easier to get rid of, but I'm not doing it yet because it's easier. I can't totally get rid of it, but I can turn it into 4 bytes, in which case it goes into a hole here and we save 8 bytes. So I have short-term roadmap for getting rid of 16 bytes more. We already got rid of 16 bytes yesterday. So that'd be a total of 32. And then here, I think this could probably be turned into 4 bytes, but the problem is that makes another hole. Also, maybe it can't really be turned into 4 bytes. I'm not sure. Certainly it could be 8. I'm pretty sure. This stuff down here is maybe harder. These might be able to go into hash tables. It's like the fact that we have 5 pointers right here is like, damn, dude, that's 40 bytes. If I could get this down to 32, that suddenly doesn't seem so terrible anymore. What about a separate list that you can just search for the asked pointer and get back the location info? Oh, hey, man. Well, that's what I was thinking of. Okay, so the way this works is the Lexer reads the tokens and they have these numbers on them, right? And then in the parser, we just copy these off. Or that's the simple part of the idea. The thing is, so what I was thinking is the Lexer can just do that, right? It could have a 4-byte integer that's like, what's the index of this location info? Because the thing is, you usually don't need the location info. There are a couple cases in which we do, but it's mostly only necessary for error reporting. So maybe if getting at it is slower, it's fine. Now that said, I think there are some cases where we use it to detect use before declare, but those are probably sketch anyway. Okay, so now the problem is, in the parser, if I remember correctly, I nudge things forward or backward by 1 character sometimes, right? And so I don't exactly use the ranges coming out of the Lexer. And so like I make a new one. So it's like, okay, well, maybe you register that new one back with a Lexer, or maybe you put it in the parser. And like, that's fine. I guess the question is just like, how many of those do we make? Or maybe you can just mutate the old range. Like if you knew this range was not being used by anybody else, you could mutate the old one. Anyway, like one of those would get it down to 4 bytes. I just haven't exactly decided which one, right? The thing is, see, this is a very uncompact representation anyway. If I were going to be naive and just store these smaller, instead of line 0, line 1 is usually equal to line 0, right? I would say line 0 and delta lines, right? And I could clamp delta lines at 1 byte and just say if it's longer than that, it's just 255 or whatever. Like, you know, if it's longer than that, then, or if it's greater, or if it's equal to 255, we saturated and we just don't report the whole range in the error. We just say the starting point, right? So this could be 1 byte or less, right? It could be 5 bits for all I care. Like, how often do you care that a range is like 32 lines? Like, you don't, right? And same with character 0 and character 1. Like, the most important thing is the initial line and character. These are just like to help out with highlighting, but you don't want to highlight a gigantic ass thing anyway, right? So if the line number, so 2 bytes of line number is not enough because you could easily have something with 64K lines, but like 3 bytes of line number, kind of okay. Character index, you know, maybe you kind of don't need the exact character index if it's more than character 64,000, right? So 3 bytes, 5 bytes, 6, 7 for delta line and delta character. So 8 bytes for this, if it's not even stored separately, right? If it's just here. So I don't know. Okay. Where? I've lost my place in the comments. What is happening? I was reading Ryan's comment. Oh, there it is. I didn't see it on the screen. I was searching for your comment and then, yeah, it was stealth. All right. When it says reproducible across builds, does that mean consistent? If so, how? Where reproducible across? Okay. Basically, we just run in a mode where we don't do things in parallel, right? And if you do that and you're deterministic, things basically happen in the same order. The gotcha in this is that user level meta programs still are what they are, and you can't really serialize something that's inherently parallel. So for some user programs that are inherently non-deterministic, you can't induce reproducibility on top of that, right? Time to use bit fields. I mean, like I said, I don't personally use bit fields. For these things, I would not use bit fields. Three bytes gives you line numbers up to 16 million. I know. You know, even 2 bytes, like, I don't know. I feel like it's a legit use to have some generated file that's more than 64K lines. Or hell, I've written individual files in C++ that were like 16K lines of just legit hand-typed code. So 64K would be too low to cut it off, obviously. But, you know, 256 times that I could get away with. So anyway, one or the other of things, I was definitely thinking about just using a 4 byte or maybe less than 4 byte integer to index the lexical range of the thing. And the only thing giving me a little bit of pause was the fact that we dynamically mutate them. But maybe that just means that the parser is the right place to put that range. I just have to survey who's doing what to sort of figure out the final decision there. Okay, I'm going to go boil the water for the final tea, guys. The water shall boil. Any other questions about this? Yeah, the other thing I want to do that's maybe more of a short-term experiment is to retry, as you can see in this comment, except it's probably covered partially by the camera. Oh, as you can see in this comment, I did a thing before where this was in a hash table in the message exporter. Like, in a heavily parallel system, you kind of just want data stored where the people are who are concerned with that data, right? So this is only something that the message exporter cares about. So you kind of want it to be private to there, but it just was slow, but I didn't realize that the hash table was broken. I maybe should have been more careful about that, but I wasn't. So I de-implemented that and put it back here. And then later I found out the hash table was broken. Now we have profiling built into the hash table so we can see, we can validate that it's performing reasonably. So we could redo that. And there were two parts of that. One is put it in a hash table, but two is, in theory, we don't need everything to be in the hash table because the main use of that hash table is to know who's been exported and be able to map, because you could sort of have a DAG, right? Multiple things pointing at the same thing. And if you're exporting, you want to point people at the exported node. Now, I had the theory going in that we wouldn't have to put most nodes in here because the DAGness should only happen in certain limited cases. That seemed to have been wrong. However, because when I went, I did, maybe I even did this on stream. I went and did a listing of who gets pointed to more than one time by node type. And it was there were hits on almost every node type, right? Which makes it seemingly not that difficult or too difficult to try to, I was at a loss as to how to do it. Oh, the water's done. But I realized since then, maybe it's really about who's pointing, right? So if something is, in the arguments block of a procedure or something, right? and that's why they're being pointed at multiple times, then maybe we only put that in the table based on who's pointing at it, right? And that's where the real wins comes from. Like, so if we use a hash table instead of this, we actually use more memory on net. It's just that we're not eating memory in the node, which probably leads to better performance, right? But we are using more memory. We're not using less because hash tables need more. We're also using more CPU cycles to look it up. On the other hand, if I was thinking about the T, so I just dropped my sentence in the middle. Oh, well, if you could only store 10% of nodes, then it's a big win over, because here, because it's built into the node structure, we store this for 100% of nodes, right? And so that's the real win that I want. All right, let me get the water. T number 5. Let's get ready to rumble, or whatever they say. Okay, here we go. Is this the familiar delicious tea? Do I still think it's delicious? Honestly, with the golden monkey that I have, sometimes I think it's delicious, sometimes I don't. All right. Oh, I'm using the wrong spoon. Hold on. We need portion control. We need portion control. 1 second. This spoon is covered with honey. Let me rectify that. Okay. Here we go. Big scoop of tea. A little bit extra because that wasn't big enough. Boom. All right. All right. Boom. Now, pouring the water in. Lid on. Starting the 2-maple timer. Boom. All right. Back to the questions. Have I figured out what is slow in the compiler? I mean, some things, but I feel like there's more than one thing. Since there's no native 3-byte integer type available, how would you represent it? It would just be a subfield of a larger integer. Or some bytes that you knit together. What about just storing an offset into the file and recomputing line and character whenever we actually need it, which is almost never? Yeah, like that is viable. That is viable. Like I was saying, there is a case where I think we do use lexical positions in the middle of the compiler, which again is a little bit sketchy, but we do. However, file offset would be equally good for that case. Maybe it's gone. So we have this A is earlier than B. Textually earlier than B. This is the sketchy one. Right, but like I said, so we're just looking at line number here, and then character index. Yeah, like offset in file would be fine for this. Okay, when do we call this? If we have overloads, Yeah, I mean, this, again, Raphael and I were talking about this a little bit, like how complicated and annoying and still not totally working right the overload stuff is, and this is a case of that. Like I had some problem where inside an enum, if you redeclare things, it goes into an overload list. You know what? With this though, because you can't have a function inside an enum, we could just flag the block as, I mean, we already know it belongs to an enum. So at the time when we normally would bind an overload, we could just do a redeclaration error there. The thing is, that sort of would be a special case for enum, but it would be less complicated than this bullshit right here. So I would actually be in favor of that, because that also lets us remove that completely, because these are the only callers of that. Right? This is an old to-do list. I need to update this on my laptop, which is not even here. Do I have time? Yeah, I have a minute to do it. I also feel that I have not been doing enough palette cleansing. Apologies, everybody. Anyway. Like anything that I can do to reduce the amount of cruft in the overload system would be great, because it's way more complicated than I wish it was. Profiling stream sometime? Yeah, we might do one. What do I mean by subfield of a larger integer? I mean subfield of a larger integer. You're bothering me about like weird pissant bit field implementation details, whereas what we care about is the math of how much information can be stored in a number. You're talking about a C programming language implementation detail, which I don't care about. All right. Sorry, I don't mean that to be too abrasive, but it's like the question is a little bit annoying. Like, what do you mean by subfield of a larger integer? I mean, your integer written in binary is a bunch of bits, and using a subset of those bits, you can represent a number, or in fact, you don't even need to be base 2, right? So you can do an arithmetic coding style thing where I actually wrote a Game Developer Magazine column on this back in the day. You can pack things according to arbitrary factors and get sub-bit amounts of information at the cost of not using the entire range of your thing and like having to do divides and stuff. Why do people think special announcement? Nobody ever said announcement. Had another bug today. Redeclaration error that wasn't raised before compile time assert went off. Yeah, I actually had one that was worse than that. I don't know if I remember enough to repro it because I was just too busy with other things. I had a thing with like array literals or something, or I had a redeclaration that never was detected at all, and the program compiled and ran and just used the first one. So that's like really bad. So yeah, that needs to get fixed for sure. Oh, guys. Okay, hold on. We need to do a little bit more cake palette cleansing. This is the last of the cake. I also feel like my tongue is a little bit burned now, but okay. Okay, I'm forming initial impressions. I need it to cool down a little bit so I could drink it in volume next. So we're going to give it a little time. Anyway, this is my quest sort of as part of my Christmas break, is to get the node size down. And maybe that'll show up slightly in the compiler performance, right? I think the bigger thing is to make the identifier look up faster, but I'm not sure which way to do that. And again, methods that would work for some compilers are not viable here, at least in terms of speed. Because we have nonlinear compilation and are compiling so many things at once. We'll see. Is cake a palate cleanser? Like, look, man, you gotta live. You gotta live. Also, some stuff like this queued here, this can even be a 4-byte or less integer, right? It's just, we probably look at this a lot. Maybe not. Maybe in an absolute sense, not. Inferred type, actually, that could just be an index to type tables. Here's the thing, guys. Okay. If there's any big question that I have in the design of the actual programming language, it is the following. For maximum simplicity, I was like, look, all pointers are the same size. I mean, you have relative pointers, but aside from that, all pointers are the same size. Arrays use full-size counts and pointers. That makes it very convenient to pass things around and all that. But 8-byte pointers are chunky, and that does matter in modern programs. You would think like computers are fast enough, but no, it matters. And so if you're trying to make a program efficient, you kind of never want to use pointers anymore because they're too fucking big. And you never need that much, right? Like, here's the thing. Yes, on the one hand, 4 bytes is not enough to reference the address space of your program, right? However, if your program's organized with respect to what it's doing, 4 bytes is usually way more than enough for any particular kind of thing that you're talking about. Like, for example, QUDs, you know, how many of these do we make right now? It's a 4-digit number, maybe a 5-digit number for the Sokoban game, right? Not that many. Inferred types, how many do we make? You know, maybe thousands again, possibly, maybe less, maybe hundreds, etc., right? So all these things are using 64 bits to represent 16 bits of information. And so if you get serious about making things small, all of these can get packed down. And then what you really want is a smaller representation that decodes into a pointer. Now, I've been thinking about this off and on. You're saying time for relative pointers? No, because these all are basically going to be table lookups in these examples I'm talking about. Now, the thing is, I've thought about this before in terms of language design, and I never came up with something yet. Maybe I will, but I never came up with something yet that was like a representation for a pointer that's really a table lookup that was actually less of a pain than just doing it manually. Because the thing is, you're probably not looking in a global table usually, right? Like here, we've got this struct called workspace that we'd be looking on, and we'd have an array of QUDs per workspace and etc. But like, how do you know what the workspace pointer is? It's like a local variable in your function. Maybe it's in the context, right? So you could maybe, yeah, like this is weird, but if we said that you generally point to something through the context for this kind of pointer, then we could just code gen it without you having this other information. But like usually it's like, okay, here's my 16-byte pointer, or my 16-byte integer, I'm going to cast it to a pointer by looking up this table. You have to say what the table is anyway. At that point, you might as well just write the array subscript. Do you know what I'm saying? Or write the getter function. Like it's not really a savings at all. So I don't know. I don't know what to think about that. x86-64 supports x32 mode. No, you can't have 4-byte pointers. 4-byte pointers are not viable. Because like I just said, your address space has to be big. Yeah, ritzy people always eat something that tastes like total ats and say, oh, it's a palate cleanser. I think I'm immune to that. Like, I don't like wine. The social signaling aspects of wine are not enough to make me like it. I think wine tastes nasty. Usually. I've had 1 or 2 wines that I liked, but mostly it's fucking nasty. The best default for you is 64-bit pointers, 32-bit ints. Yeah, but when you design a programming language, it's bad in 2022 to have your default int not be able to hold the size of a typical file. And it's very easy to have files more than 4 gigs accidentally, right? So like, you kind of can't default to 32-bit ints. Now, letting people use 32-bit ints, that's fine. Anyway, I guess what I'm saying is here, these are all going to turn into table lookups. And then what happens? I don't know. I mean, we use half the memory, right? Because it's it's a no-brainer to make each one 4 bites. Oh, you know what? I didn't put my score from before the honey. I said I was going to drink it in volume and I didn't. But here's the thing, guys. I'm adding a digit because I don't want to give it a 6.9. I did not like this one that much. Which is weird because it's supposedly my favorite Golden Monkey tea. But it's in a different packaging. It's like a different... I don't know what's going on. My whole reality is being shook right now. Okay. So now we've got some milk and honey. Yeah, I don't know, guys. I don't know what's going on. I will say this is better. I'm going to give it 8.2. So I think actually in a surprise upset, the Tea Bloom Masters Select Collection wins the Battle Royale. With merely an 8.3, which is insane. What did we learn today? We learned that Golden Monkey isn't very good, which kind of shocks me. You know what, though? Like, okay. We're in 2022. I feel like so food quality across the board went way downhill in 2021 and 2022, right? Just like everything became cheaper and worse. You go out to a restaurant, it's bad, right? I wonder if that happened to tea. It happened to chocolate. Chocolate sucks now compared to 2019 chocolate. I wonder if that happened to tea. It happened to the seaweed crunches that Casey and I liked. They're terrible now. Same brand. They changed their packaging. They changed the contents. So I wonder if that's what happened here. What score does a supermarket Earl Grey get? Oh, that varies. Like some Earl Greys are really bad. Some are really good. You somehow would never trust tea off Amazon. I mean, maybe I shouldn't. The previous packages, I had some really delicious times with. Here's the thing. We're going to keep the Full Chi and the Tea Bloom Masters collection, and we'll just have them off and on during streams. We'll experiment with different amounts of steeping and have lots of milk and honey, and we'll see how it goes. But like, I don't totally love either of these right now. And I'm not sure what happened. I expected higher scores across the board than what we saw today. By the way, since we're talking about Amazon, you know how much we like our educational videos. We're going to watch an educational video about how to shop on Amazon. All right. We may not watch the whole thing. Hold on. Here we go. You know how important it is.
This video is sponsored by Mind. More about them at the end of the sketch.
Is that my chair?
Hey, Amazon, I need a new chair. Oh, hey, man, you want to watch Jack Ryan? No, I'm good. Wheel of Time? Just the chair is good. I'm thinking one of those gaming chairs. Oh, hell yeah, man. I got a bunch of those over here. Okay, yeah, great. What's the first one? First one right here is great. It's the gaming chair, racing office chair, high back computer desk chair, PU leather chair, executive and ergonomic swivel chair with headrest and lumbar support. That's the name of the product? Yeah, pretty catchy, right? No, that's just a jumbled mess of search terms. Yeah, that's how things are named around here. Pretty catchy, right? You want to see some others? Yeah, yes, please. All right, here you go. Pretty nice chair also. This one's nice too. That's the same chair. Oh, actually, no, it's not. You're stupid. It's not. But yes, though. Nah, because see, this one is the gaming chair, adjustable ergonomic office chair with PU leather computer chair with lumbar support and 180 recline, easy to assemble and comfortable. All right, I don't want to know the names anymore. Can you just show me some more options? Of course, my man. We got all of these, actually. Okay, those are all the exact same chair. No, these are all from different brands. Are they? You know it, my man, and we're talking top brands here like Floor Goo, what? Cremplo, Barbentron, Zalimio. Those really don't sound like real companies, Amazon. But they kind of do, though. You could see how those might be company names. I guess. Oh, actually, we got that new Wasus chair. That's Amazon's choice, that one. What does that mean? Does that mean that that's the best product? Not necessarily, no. That's, all right, let's take a look at the reviews of the Wasus chair, I guess. Oh, yeah, good call. It's got 17,000 reviews and averages 4.5 stars out of 5. Really? Yeah, pretty great, right? Suspiciously so, yeah. Here's the top review. Let's see what it says. 5 stars, great product. That's super vague. No, this person specifically thought the product was great, it seems. I gotta be honest, that didn't seem like a real review. Okay, well, how about this one? 5 stars. I bought this product for my husband and he loves it. That one has a backstory, kind of. Right. I think I've seen that exact review on every single page of yours I've ever been on. Is that possible? Hey, man, a lot of people buying products for their husbands, a lot of husbands loving those products. Maybe I'll check out the 1-star reviews, see what people don't like about the Wasus. Sure, here's one. 1 star, package arrived damaged. That's not really helpful. That could be a shipping issue. Here's another one. 1 star, there was a screw missing and I contacted customer support and they sucked. That's all right, still haven't learned much about the chair here. Let's read some more. 1 star, my uncle died in this chair. He had a heart attack and we found him 4 days later and it stank. Good chair though, nice lumbar pillow. Oh my God, that was confusing more than anything and way too personal. Yeah, sometimes people get way too personal in their reviews. We don't know why they do that. Okay, so I feel like the 5-star reviews are fake and the 1-star reviews are insane. Maybe let's check out the middle ground a bit. Of course. 4 stars, chair look good. I knew that from the picture. I know that chair look good. Let's read another one. 2 stars, cheap plastic, chair broke when I jumped on it. Well, why'd that person jump on the chair? I don't know, here's another one. 4 stars, honestly provides really good support. I was concerned after reading some reviews, but it's great. My back feels fantastic and it looks amazing. Oh. All right, I mean, that seems real, and that seems pretty good. Yeah, pretty good chair, the Wasus. All right, great. I mean, maybe I'll check out one more review just to be sure. You got it. 2 stars, chair's not great, and just so you know, the company offers you a $10 gift card to leave a positive review. Okay, well, that shouldn't be allowed. Yeah, kind of hard for me to do anything about that. Not really a problem, though. Well, that makes it really hard to trust any positive review. Yeah, I just want a chair, Amazon. I fell on my butt. I have chairs. Do you? I can't tell if any of these are functional chairs. Roll the dice. Oh, my God. Maybe I'll just get a standing desk. Oh, I got some of those. Check this one out. I bought this product for my husband and he loves it. That's okay, I'm done. Hi there, hello, it's me, I'm the...
All right. So this was the Ryan George YouTube channel. This Twitch channel is sponsored by Ryan George. You can go to his YouTube channel and see many fine educational videos such as this one. Well, we might be coming toward the end of the stream here. I'm a little bit sad about these scores. I wanted a 9.5 from the judges. We did not get that. I don't know what to think. Anyway, I'm kind of trying to take some days off this week, including much of today. So, you know, I might work a little bit on this aforementioned stuff that I aforementioned to you. But yeah, I think a lot of these pointers is going to become indices. And then this is going to go away and we'll do something about this. And yeah, I don't know. We're going to see. We're going to see. Gaming streams. Oh, you know, so Casey and I played a game off stream that I could point out to you guys. It's pretty okay. You might have fun playing it. However, it tops out and is not as fun as it should be in the end, but we played for 10 hours. It is this game called Ship of Fools. It is pretty interesting and worth playing. But also could be better. What achievements did I not get? View my achievements. Destroy 10,000 sea monsters. Destroy 1,000 sea monsters. Max out a cannon. Wait, why didn't we get that one? This one's broken. We did that. Complete solo run. Destroy 100 sea... Wait, how did we not get destroy 100? Casey must be getting these only because he was hosting the game. We fucking destroyed more than 1,000 fucking sea monsters, dude. Rigged. Rigged. Anyway, it's a fun game, but I feel like it needed more work and they just released it. Or something. Let's see what's on the wiki. I clicked on the link and it just brought me here for some reason. Ship of Fools film. Game. This is not... Can I copy link? Computers just don't work, guys. I can't copy the link. Clicking on the link. Oh, wait. It's working this time. Okay, here we go. This looks like a very low fucking effort wiki. What do I think about it as of today? I mean, everything I said in that speech is still true, only slightly more so than when I gave the speech 3 years ago. Ooh. That one's nuts. So our best one was this one. This one was insane. Gain 1 sand dollar every time you hit an enemy with a projectile. That's OP. And then we also had a perk on that run. that was basically, I forget which one it was, but it was basically you do damage proportional to how much money you have. So we had this thing generating money, and then we were doing damage based on, I think it's this one maybe. The scrotum purse, yeah. I don't know why it's a scrotum and or butt purse, but that's the art they put here. That's just what they did. I did not art direct this game. Anyway, the game's worth playing. It's just, it's one of those shames because you can see the delta between where it is and where it would be best. And the question is, are they still working on it? Are they going to expand it like happened with Isaac? And I don't know the answer to that. I don't know the answer. The missile knows where it is. You watched Severance and enjoyed it. Good. It's a good show. Freezing ammo is busted. It needs a nerf. I mean, the game is super unbalanced, right? Some stuff isn't worth using at all. Other stuff is OP. I think that part of the problem with the game is that movement is not that much of a thing compared to, for example, Binding of Isaac, right? And because of that, things are just less situational because you're either there in front of the cannon and just shooting dudes from one fixed position, or you're, trying to melee dudes off the boat. Like, it tries to give you reasons to run around the boat, and you do that a little bit. But like in Isaac, you're normally just running all over the place naturally, and it just makes a big difference. So I feel that constrains the possibilities of the game a long time, or a lot, and means there is less opportunity for situational factors to even out balance. So everything is more like scalar, right? So like we tried the alternate cannons and they all sucked, right? So like the first thing it gives you is like the charge up grape shot cannon, which is terrible compared to the default cannon. Like, why is it even in the game, right? And then we tried the dually cannon with like the 2 ammo types, and that was not good. It just, all these things, when things are automatically ranked scalar, it's like you can't balance them if they're actually different from each other. The only way to balance things is to make them the same. So why does everyone think announcement? Nobody said announcement, guys. Nobody said announcement. Holy crap. The announcement is we drank a lot of tea today. And like the game tries to make you come off the cannon a lot to reload, right? But that's actually just kind of tedious and bad. Like in a, in like a shooter, when you reload, you're doing something. You're like ducking around a corner. You're like looking around. you're thinking about what to do next, etc. Right? In like Ship of Fools, when you reload, you're just running to the load position and back. Like it's not. I wouldn't, for how uninteresting that is, I wouldn't make it take up the proportion of gameplay that it does. You know what I'm saying? Like some stuff needs to get worked out. Raphael said announcement. Oh, he misinterpreted my thing. Okay, there's not an announcement. There's not an announcement. It was just a special stream. It was a special stream involving Golden Monkey Tea. That is what happened. That is what happened. It was not an announcement. The announcement is we're working on stuff. Ast struct soon 32 bytes total. I mean, I hope I can get it down that small. I would like all right, guys. I feel like it's about time for me to go out into life. Raphael said he thought it's just likely about some back-end speed related thing. Yeah, well, he knew what I was working on, but no, there's actually not an announcement. Golden Monkey. Yeah, I'll see you guys next year for Golden Monkeyfest 23. Thanks for coming by. We might do a stream tonight. We might not. It depends on just how much I want to chill, because I am trying to have a break until the 25th. But I like programming, and so I end up programming a lot anyway. Am I announcing Elder Scrolls 6? I am announcing that we're releasing Skyrim for compile time execution. It is compile time execution Skyrim. All right. Thanks, everybody. See you later on.